You're listening to the Washington AI Network podcast, the winner of 2 2025 Communicator Awards. One for excellence in the science and technology category and an award of distinction for our episode on healthcare AI, featuring tech legends Ted Leonsis and Grant Verstandig. I'm Tammy Haddad, the founder of the Washington AI Network podcast. Before we begin this week's episode, I'd like to invite you to join us at the inaugural AI Honors on June 3rd at the Waldorf Astoria Hotel in Washington, D.C. This black-tie dinner, awards ceremony, and exclusive after-party will convene 300 of the most influential leaders in artificial intelligence, from policymakers and industry to academia and civil society, to celebrate the extraordinary individuals shaping the future of technology and innovation. Visit aihonors.us to learn more. I hope to see you there.
Designed to enhance U.S. competitive advantages, the AI Plus Expo unites leaders who are shaping the future of emerging technologies. Attend for free June 2nd through 4th in Washington, D.C. Visit expo.scsp.ai.
Welcome to a special edition of the Washington AI Network podcast, recorded live at NVIDIA's 2025 GTC, their annual global conference that brings together developers, engineers, innovators, educators, the entire AI ecosystem. I'm Tammy Haddad, and today you'll hear from 4 incredible people I met in San Jose, each harnessing the power of AI. We'll start with NVIDIA's very own Dion Harris. He is leading NVIDIA's efforts to bring advanced AI and high-performance computing solutions to market. Then I'll speak with Moritz, Baecher, and Espen Knoop from Disney Research. Yes, Disney Research. They're in a partnership with NVIDIA. If you listen carefully, you might just hear their robots. And finally, I'll discuss using generative AI to accelerate B2B sales with Navanee Sundaramoorthy, co-founder of Rapidflare. Now let's hear about NVIDIA's role in all of this from Dion Harris. We're here at the NVIDIA booth, and I'm talking to Dion Harris, and you're the big guy in charge of accelerating compute. So every single person here needs what you do. You don't feel any pressure, do you?
No pressure at all. It's a team effort. I know I have a lot of people supporting me, so I have no pressure at all.
Okay, so there were a bunch of announcements made by Jensen yesterday.
Yes.
What do you think were the 2 most important?
I think the 2 most important announcements that we made yesterday were basically our OS for the AI factory. He framed that as Dynamo. And so that's basically the system that will allow all of these companies that are looking to deploy AI to be able to deploy it in the most efficient and productive way possible. The other thing that was really important in terms of his announcements was how we're driving the ball forward with our roadmap, and we're announcing, our GB300, which is what we announced yesterday, and then we also highlighted the next gen platform, which is our Kyber NVL 576 GPU rack. So those 2 combinations of things are really what's going to unlock the potential for AI factories for all of these incredible use cases.
So the most surprising thing to me was the integration that NVIDIA is in at every level of research, of companies, of countries. So is that new, or have you been doing that for years?
NVIDIA has been, a pioneer in delivering what we call accelerated computing. The unique thing about accelerated computing is it requires very specific engagement and integration with the application itself. And so all of those CUDA libraries, those domain-specific libraries, is just another instantiation of that, because basically, in order to leverage computing and accelerated computing, you really need to be able to have the application talk to that underlying hardware. And so we've basically been doing it domain by domain. Like if you look at some of the early use cases, they were all scientific computing bases, whether it was physics, molecular dynamics, climate and weather. And so as we've moved from each domain to each domain and adopted different use cases for accelerated computing, that's always been the bedrock of sort of our platform, is enabling developers to take advantage of it. And that's why we're here at GTC, which is all about developers, all about celebrating the work that they're doing on the platform.
Okay, data centers are so critically important. We're the Washington AI Network. We talk about it all the time. Virginia is the capital.
Yep.
I'm not going to ask where your data centers are, which ones you're working on. I know you're working on all of them.
Sure.
But the issue is making the GPUs more efficient. And I think
Yes.
that was one of the other announcements.
Yes,
How do you do that, and when will that go into place?
absolutely.
And people will see the actual results.
Yes. And so when we talk to a lot of our customers and partners, even in the keynote, I think Jensen highlighted that most of them are figuring out how they can get the most out of their power envelopes. In other words, how can they drive more productivity, more revenue out of their existing power assets? And so what we're doing is we're driving as much efficiency as possible out of the solution. So we announced our GB200 NVL72 last year, and that was going to deliver 25 times more energy efficiency than our current Gen Hopper platform. So again, very much designed and built with the idea of how can you drive more compute density, but also much more compute efficiency. So we see a lot of these systems coming online. In fact, during the keynote, you saw all of those, great OEM systems that are being deployed. And so I expect this year we would see a lot more efficiency coming out of the data centers that are being deployed.
Okay, let me use an old-fashioned word. But are you saying that the current systems are being upgraded? Because it sounded to me like that was the first time that I heard that this new technology will allow you to do that.
Yeah, absolutely. So when you think about how the data centers are ran, most providers, most builders will build on the current state of the art, and they'll deploy what they can today. Hopper was by far the most advanced and efficient architecture that was available for AI researchers and AI factories. However, as we move to Blackwell, it is truly, sort of leaps and bounds more efficient and more performant than even the current Gen Hopper. So this is where we think, when we describe how builders have to make this sort of decision of, okay, do I stay where I am or do I embrace the new architecture? And given the performance and the efficiency, everyone's moving to Blackwell.
Okay, what about sustainability?
Yeah.
And I want to talk to you about the weather, because when I
Absolutely.
see all this technology, I think, for God's sake,
Yes.
please use it to figure out the weather.
Yes.
I'm not talking climate change, but we can talk about
Right,
that.
right.
But I'm talking about just weather.
We've done some incredible things to enable the climate tech ecosystem. In fact, we have a project called Earth 2. What Earth 2 is, it's an initiative to really harness the power of what we do at NVIDIA. So taking core simulation, accelerating it, making it faster, more efficient, taking AI and AI surrogate-based approaches, and making that whole prediction process much more efficient and streamlined, and even taking digital twins and using that to represent and share all of that data so that we can democratize a lot of the use cases. So looking at a couple of announcements we had here at the show, one was we were working with a company actually called G42 out of UAE. And so we've been working with them to institute accelerated computing to help them to accelerate their climate tech platform. And they're able to take some of these AI models and develop highly resolved, very localized models at 200-meter resolution. That would take a supercomputer, but they're able to do it leveraging AI with 10,000 times less energy and less compute resources. So that's an example where we're taking a lot of these technologies and bringing them to bear, especially for the climate tech ecosystem.
Do you feel sometimes you guys are bigger than the government because you're leading on innovation in the US and around the world? Do you ever think, oh my God, well, look at what we're doing? Because governments come to you.
Well, I think NVIDIA has always had an ecosystem first sort of mentality. We recognize the importance of our developers, the importance of our partners, and the importance of government. We're working with every government, as you described, to help. And oftentimes when we're bringing our solutions to bear, it's trying to figure out how we can help them solve a problem or a solution. And you mentioned, climate tech is one where we're literally offering our entire portfolio to figure out how we can help accelerate and streamline a lot of those processes. But also within the public sector, we have tons of different use cases and applications where we try to drive value as well.
Okay. Also, there's this ecosystem with the companies, right? Yeah. It's not about the name of a company, it's really about the cloud, because it's not just compute, it's the cloud. So how do you decide who to partner with? Like all the developers here, do you say, hey, maybe you should talk to this person or that person? Because I feel like you're a little bit like Google search used to be like, okay, who's the best partner? Right. I would ask you. Do you guys get involved in that kind of advice?
So the one thing about NVIDIA, we're the only AI company that works with every other AI company, and that is by design. In other words, we're a platform company and we want to enable everyone to do their life's work. And so we don't pick or choose or recommend or decide where a customer goes, but we're willing to support them wherever they are. So if they want to run on the cloud, we're in every cloud. They want to deploy an OEM system on-prem. We're supported by every OEM. So we want to make sure that our platform is ubiquitous such that whatever choice they make, we can be there to support them.
Okay, I have one more question for
Sure.
you. What is the craziest thing that anyone's ever offered you to get higher up on the line for GPUs?
You know, I've had a lot of really fun offers, but I'd have to say the best one is my daughter. She's offered me a massage and pampering if I could get her a robot.
Oh!
And so she literally has asked me several times.
Well, what kind of dad are you? You need to get her a robot.
I'm working on it. I'm working on it.
All right.
Exactly. Yes.
Dion Harris, it's so great to be with you here.
Thank you
so
for
much.
having me. Thank you for having me.
Thank you.
Absolutely.
That's
Absolutely.
NVIDIA's GTC rivals Disneyland for the happiest place on earth. That's why we must hear from Moritz Baecher and Espen Knoop from Disney Research about their tools to design and develop believable, emotional robot characters. Hi guys, can I ask you a couple questions?
Sure.
Okay, what are your names first of all?
Moritz.
Hi Moritz.
Nice to meet you.
Nice to meet you. It's Washington AI Network.
Hi, I'm Espen.
Espen, it's so nice to meet you. Tell us about your friends that just dazzled this conference of 25,000 people.
Yeah, so it's our little Star Wars droids that we actually created at Disney Resort. So they took first steps in a lab in Zurich, Switzerland. And since then, the early stages, we brought them to the parks. It took us less than a year to develop them from concept to fully fleshed droids, 3 of them fully themed, that we play tested at the park at Disneyland for a day. And the technology behind it is basically modular hardware components that we can quickly put together, customized, and then reinforcement learning. Reinforcement learning lets them learn or enables them to learn in simulation to walk, like this, for example. They literally learn to walk in simulation. And what's the Disney magic is that they learn at the same time to follow artist-provided motion. So that's sort of our secret sauce. We care about characters. We care about artists having full control of characters. We abstract the complexity of a physical system so that artists and creatives can actually focus on the artistic aspects. But technology helps us to make characters really become believable characters. So here you see a robotic character. You don't see a robot, not a mechanical system. And we do everything that we possibly can to make them believable. So for example, we generate even sounds. So you have actuators, and the actuator velocity, based on those, we actually generate sound on board, mechanical sounds that make them sound like droids.
How do you make this sound?
So this is based on some audio clips, but also we use basically sounds that we then modulate and use for generation of mechanical sounds. But some of the sounds come actually from the BD unit that first appeared in the Star Wars Fallen Order computer game. So that inspired us. So it's a different BD unit, but that served as a source of inspiration. We used some of those sounds, these ones as well.
So you guys are a new kind of Disney magic, right?
It's new Disney magic, pretty walking characters. We believe that this is the future of storytelling, because you can tell non-linear stories. And our guests in a park environment, in our lands, can actually co-direct stories. You can have meaningful interactions with these droids, something that we have never been able to do before.
Have you shown this to the animators?
Oh, absolutely. We have actually animators on our team. When we started working on this droid, we had a full-time animator on a very small team, and obviously that's very, very important to have creative involved in the loop from the beginning.
So an animator in the loop,
Yes.
in AI.
Absolutely.
I like that.
Absolutely.
Yeah,
Okay.
exactly.
And you work there too?
Yes, I'm the mechanical engineer behind the project. So during the development, it was definitely a close collaboration between the mechanical design and kind of the character development and the animation and the motion and the control RL, kind of the full stack, all working together to create the character. And I think that's kind of part of what made it come together so well, is that we could all work together.
So you have these characters in the park sometimes. What do you do about kids running over to kiss them?
It's worked really well so far. We've not had any issues.
So I can answer that. We have obviously very many safety mechanisms in there. So you see that droids are currently remote operated. You have protocols in place, so if someone will come too close, there's a feature called motion stop, so they just stop and freeze the actuators so they can't hurt anyone. Yeah. So safety is obviously a high priority for everyone.
Of course.
At the Walt Disney.
But they're so cute, I want to hug them.
Sure. Yeah, hopefully at some point in time we can.
Okay, I like that. Well, what are their names?
They are BDX droids, but that's Besh and that's Grok. Gave the individual droids with different colors names.
Okay.
Besh and Grok.
I see. And do they have different personalities?
We do give them personality, so what's actually quite exciting to us is that all of them are controlled the same way, but the operator can give the droids personality. So we can actually demonstrate that quickly. So David, can you make your robot being shy for a moment? So you can see that. So it lowers its head. As an operator, you are basically a creative director and can give them a personality.
Well,
so
you've accomplished a remarkable thing. I've seen a lot of robots, but these ones have emotions.
Yeah, exactly. So, the first thing that we worked on is stylized walking, but that's sort of the functionality. But then we thought, what's the next step? Well, a character needs to be able to emote, as you just said. Emotions are very important, and so then we introduced short animation sequences that we then learn to follow again in simulation, so that they actively balance at all times, or actually safe systems. But yeah, we have different emotions that they can express, happy dances, so to express happiness.
Oh, I like that happy dance.
But also angriness, right? So for example, if someone comes too close, you can actually show that the robot is a bit angry, or you should take a step back. That's quite effective. So if you could turn it around, and so if you could for a moment just express that you're angry.
Oh,
right? So
and the
it's
red
very
lights,
effective.
red eyes.
Exactly. So if someone comes too close, especially also with our younger guests, it's quite effective to keep them a safe distance away at all times, right?
So there's only one final question for you two. Have you volunteered these incredible robots for an upcoming Disney film?
That's correct. They're going to be part of the Mandalorian and Grogu movie. And we're super thrilled about that, obviously.
I bet.
A character that first took steps in a park and then made it into a movie. That's obviously fascinating. Right?
Inspired from a video game as well.
Yeah. Inspired originally from a video game, right? So the BD units, bipeds that are smaller, served as a source of inspiration. This is a larger version, right? But from a game to a character in the park to a movie. Yeah.
Well, gentlemen, are you going to get producer credits on that film?
Colin said we would.
Who knows what was in the credits there? Who knows?
Yeah, hopefully. Would be nice.
Well, congratulations. This is incredible work, and it's so nice to meet you here at GTC. Thank you.
Too. Thank you.
We'll close with Navanee Sundaramoorthy, who is striving to answer the question, how will AI systems communicate with one another? His company, Rapidflare, may have the answer. I'm here with the founder and CEO of Rapidflare, Navanee Sundaramoorthy. Okay, first of all, tell me what GTC means.
GTC used to be about graphics technology, but now it's about GPU technology conference. GPUs power pretty much 90% of all AI in the world. So this is a conference that talks about the core physical electronics that power all AI that we see in the world today.
So we're surrounded by 25,000 people, all of these incredible engineers and companies. And what are you doing here?
What we do is basically AI-based tools to accelerate business for these electronics engineers. So all of these guys build amazing electronics. We're focusing on building tools to help them with their business process, specifically the sales and marketing processes. We're helping them with AI tools.
Right. How did you get into this business? This isn't your first rodeo, is it?
No, it isn't. So we've been doing AI for 10 years, but before that, for the last 25 years, all my co-founders, four of us, for the last 25 years have been in electronics. We were at Xilinx, a chip company. We've been working on chips and building electronics and enabling people to build software and systems using that. So we understand this domain really well. So what we are doing is we are creating AI tools that can understand deep technical product information.
They're agents, right?
Yeah, they're agents.
You're actually making the agents people are
Yeah.
talking about.
That's correct. One agent is, for example, the most basic one is called a conversational agent. And let's say you want to understand about NVIDIA's latest new server processor. You can talk to our agent, and the AI agent will say, oh, this is where you can use it. This is how it works. This is what it is compatible with. This is how it compares with it. So it'll answer all detailed technical questions, so you don't have to read thousands and thousands of pages of documentation. You can just talk to the agent, and the agent will give you the answers.
So you're like deep research for engineers.
Deep research for electronic systems, basically.
Now, I know you were at AMD,
Yeah,
right?
that's correct.
And other companies, and here you are at NVIDIA. And I just have to ask you, did you ever think that Jensen was going to pull all this off?
No way. Like, it was kind of a small niche technology, mostly gamers used, or most computer you use a GPU card. It was a small thing. I remember buying NVIDIA stock at $3 and selling it at $8.
Oh my
and I
God.
thought I made a profit.
Oh my goodness.
And none of us in the industry expected it to be this big. And it's really all the applications that have been built on top of the platform that makes it possible.
Well, that's what's interesting here, where you see very niche and then very large companies
Yeah.
that are taking this new technology.
Yeah.
But it sounds like you're in this unique position where you're, okay, you want to do this and you want to buy these GPUs, but maybe you don't know how to operate them.
Yeah, I don't know how to operate. It's both pre-sales and post-sales. Pre-sales, which one do you buy? Because there are different variants, like NVIDIA sells 1,000 varieties of chips. For what you're doing, let's say you're doing a robot, maybe you're doing an unmanned aerial vehicle, you're doing a drone, you're doing a camera, you're doing an agricultural equipment, you're doing a data center. How do you know which product from NVIDIA or any other company to choose? So our conversational agent, which understands all these devices, will be able to tell you, oh, this is your use case. These options might be better fit for you. So that's what we focus on building.
So I just read Fei Li's book, and it tells a story about how she started, and she had these poor students that had to put like 25,000 pages into it. Is that what you and your partners had to do to put all this technical information in?
Right. So we basically have to take all this content, and our tools will have to just understand it. But it's not all fully automated, because what we have to do is we also have to verify that the system is correct. And how do you verify it? You have to have a human in the loop to validate. In AI, we talk about accuracies. It's always benchmarked against a human verified ground truth. So we have customer success team members who are electronics experts who can understand these documents and say, oh, this is the document. Once it's ingested, this is the question. Is the answer correct? And they have to validate it. So the human element in this is very important.
How big is the team?
There's been about 20 people now.
20 people.
Yeah.
And you just got a big chunk of money. So good for you.
Yeah, a little over a year old, and we raised a small $2.4 million seed round.
I'm just struck by agents, and I just think it feels so hard to imagine that you're going to give your credit card information, your financial information to AI to make decisions and expenditures. So what kind of safety things do you have in place?
Right. I mean, you make a really good point. One of the fundamental questions that is on everybody's mind in AI is, how reliable is it? How accurate is it? How can I trust it? Can I understand what it is doing? Is it explainable? These are key questions. And especially the focus that we have, the target application we're focused on, there is no scope for hallucination. When a product is X megahertz or X megabits or certain spec, there is no scope for us to hallucinate on it. So how do you build AI that is reliable, that you can look at it and say it did the right thing, it's explainable? So that's a big challenge on everybody's mind, and that's one of the problems we're tackling, is explainable, reliable, and trustable. It's actually on my back.
Oh, you got it right on your shirt. That's so smart. So Are you working with companies like Meta or more of the smaller companies or both?
We work with very large enterprises, but not consumer-facing enterprises. We work on large enterprises who are designing these complex systems. We work with semiconductor chip companies and those who use it. We work on electronic system companies. So, for example, industrial companies that are building these industrial machinery equipment, when they're building, let's say, a new factory to manage oil and gas, which equipment should they choose? Each one has detailed thousands and thousands of pages of documentation that if they choose the wrong one, they could lead to a lot of wasted time and cost. So we help them choose. So whether it's electronic systems or security camera systems, let's say you have to build a new security system for this building. How do you choose which cameras you will put? How do you choose which networking device to connect it to the internet? So we help in the sales process of physical security camera companies, semiconductor companies. So everybody who's doing electronics and there is a detailed technical specification, then we are able to help them. We can help them save hours and hours of time. Yeah.
Well, last night when we met, there was someone there from an oil and gas company. Today I met two more people. One's very big, famous one.
Yeah.
And one who's LNG in the state of Pennsylvania.
Yeah.
So this whole industry begins with one thing, power.
Yeah.
What's your take in the larger picture on power for AI?
Yeah, so power for AI is a challenging thing in terms of there is a lot of power consumption that AI people are worried about. But if you actually think about it, if that saves time, let's say you're building a factory, and let's say the AI helps you build a more efficient factory that is 10% more efficient. In a year, this power that is saved there will easily account for the power for the AI. So in that sense, if you look at the bigger picture of what the AI is enabling you to do, it's a win-win. It is clearly a win-win, and it's going to be a win-win. That's why people are willing to pay for AI, the cost it incurs, right? So the savings you eventually get will more than work out for the power we spend on the AI.
I see. Well, right now it's about data centers.
Yes.
So how close are you to a data center? Because every foot costs you more money, right?
Yeah. We're in Silicon Valley right now. We're surrounded by data centers. If you drive out like 3 miles from here, there's data centers all over. In nook and corners that you will be surprised. There are smaller data centers that you wouldn't even think it's a data center, and they're rapidly becoming smaller data centers as well. So there's a whole compute pyramid on the edge that we talk about that could be on your phone or laptop. And there is AI compute on the local edge devices at a building level. Your cell tower has AI compute now. And then
I saw a guy from AT&T.
Yeah, AT&T Verizon, they're putting AI compute on the edge, and then in the real data center far away near power stations. So there's kind of AI at different levels that are powering what we do. For example, your audio processing, you might do it closer. For example, Cloudflare has AI just sprinkled everywhere, wherever they are. And there's like thousands and thousands of nodes where you can do AI. It's not in one place.
All right, what about quantum? I went to the quantum section, and the questions that were asked, the quantum guy said, I don't know the answer to that. But 25 other people that were there had them. So there's this whole division. Do you have a view of quantum? Are you guys working in quantum?
We're not working on quantum, but some of our customers could be using quantum or building quantum. Anybody building complex technical electronic systems are our customers, so we would be working with them. Our own software runs on normal AI servers. Just a little point on quantum. There's a lot of confusion about like quantum compute will, kill all of the compute. Your cell phone is not going to become a quantum computer in any foreseeable future. Your laptop is going to be the same based on normal electronics. Quantum solves different set of problems that are almost impossible to solve today. In that sense, it's going to be a mix going forward as well. Even when quantum is there, it will solve certain problems that today we don't solve. So it's going to be a marriage and combination of existing what we call digital electronics or CMOS electronics and quantum. So both will coexist for a long time.
Well, along the lines of quantum, being in Washington, we're always worried about national security. And if quantum kind of breaks the encryption of AI, do you think that's all theory, or is someone, say, right down the hall is doing this right now?
A lot of amazing engineers are working on this stuff. They've been talking about this for the last 10 plus years now. So there are existing protocols which are quantum safe. There's a lot of work going on. It's just like if you remember the Y2K scenario, you remember the Y2K?
Oh, yeah.
It's exactly like that. It's just, we don't know when that date is. There we knew exactly it was that date. Here, at some point when the quantum thing just comes in, we've already been working towards it. And there's a lot of momentum that once we know a concrete date, I truly believe in human ingenuity. And we are amazing at coming up with solutions as humans.
Right.
So I'm sure we'll be able to solve the quantum wall.
Okay, don't worry about that.
Yeah.
What do you worry about in AI?
What I do not worry about, to be honest, is AI becoming rogue, coming and taking over and killing humans. Human ingenuity is amazing. We can solve problems either through technology or through politics here in DC, through the right political mechanisms of government. We can solve various things. We'll be able to control it. But the bigger worry is it's a dramatic change in a very fast way. The progress in AI is happening so quickly. The job impact on people is happening much faster pace than what it took during onboarding of computers. I mean, we had a nice luxury period of around 30, 40 years. Gradually, computers crept into our lives, and we were able to adapt to it. AI is creeping into our lives extremely fast. For every human to adapt to it will take time. I was just in India, in my native village, a month back. There are people who are not comfortable or have not seen ChatGPT. They don't know the value of it. So you don't want people being left behind, right? So everybody quickly adapting to how to use AI so that they're more productive. That is a challenge. It's the human challenge of how do we equip everybody, train everybody to leverage the power of AI.
Whose responsibility is that, though? That's the thing, right?
Yeah.
Government, and certainly the current administration, doesn't look at it that way. You know, the Fortune AI editor wrote a book, and he talked about the robot tax.
Yeah.
Companies would have X amount of dollars aside for every job they replace. That's not going to happen here.
Right. Yeah. But I think it's more than just government. Government is actually slow. They're not good at coming up quickly and adapting. I think it is all our responsibility, is my view, that all of us are responsible to make sure, you know, especially people working on AI technology, it's their responsibility to work on making sure the most number of people are aware of it, are able to learn it. Otherwise, it's just going to shut down the growth of AI. So we better do that.
Better do something.
Better
you know,
do something.
I was at the Paris AI Summit, and one of the things the French government talked about is investing in public interest AI.
Yes.
But again, I don't think it's going to happen here.
Yeah.
Or it's not going to happen right now till it's somebody's advantage to do that.
Correct. But actually, interestingly, if you think about it, anybody who has a phone, and almost most of the world has now got a phone, now has access to AI. We don't need to go to a university to pick up AI. Like I sat with my uncle who was a farmer about a month back, and together we were using AI to see how he should water the mango trees in the farm. And it's accessible to him on his phone. He just needed to install the app, and now he has access to it. So in that sense, the fact that AI is also accessible to everyone makes this possible. It's just the mindset. As long as we have the mindset, you don't require insane amounts of investment by the government to do this. You don't need to build a new university. You don't need to build physical infrastructure to enable this to happen. It's just the mindset is more important.
That is so well said. Navanee, I'm so glad to meet you, and I appreciate this interview.
Oh, wonderful talking to you, Tammy. It's fascinating.
Thanks for joining us. Come to Washington. I have some political people you should be talking to.
I would love to.
Thank you again.
Thank you.
Thank you for listening to the Washington AI Network podcast. Be sure to subscribe and join the conversation. The Washington AI Network is a bipartisan forum bringing together the top leaders and industry experts to discuss the biggest opportunities and the greatest challenges around AI. The Washington AI Network podcast is produced and recorded by Haddad Media. Thanks for listening.